Collision checking for 5-axis milling is very important, and Esprit gives us the capability to build our work holding to represent a virtual digital twin for the programmer. As more OEMs develop collision models for us to use, we can really increase confidence in the NC code we send to the floor. So let's get started. In this tutorial, we're going to use the solid model from a company called 5th Axis, and we can see that as you import this solid model from their website, this is what it's going to look like. So let's check out their website here. And if you go to the website 5thaxis.com and go to their products drop down and go to top tooling for 52 millimeter, you can come down here and grab this one right here. This is the R52P4DM25. And once you download that, you can unzip it into a folder, and then we can go ahead and have you follow along. So this is the way that it comes in, and the first thing that we want to do is orient and position our model so that it's located properly, because everything in Esprit has a reference point just like on the machine. So we're going to use the 0 point here to reference the bottom and center of this fixturing element. And what I want is to have my z-vector pointing from the bottom center up toward the workpiece. So we can see that it's not centered. The first thing that I'm going to do though is just go ahead and click on the bottom face of the model, and it's hard to see because it's blue and the highlight color I'm using is blue, but if I go to a clear view, you can see I grabbed that bottom face there. You could see a little bit of a color difference. And then I'm going to come to manipulation, and I'm going to click this first down arrow, and I'm going to say align Z, but I'm going to hold my shift key down when I do this. So when I hold the shift key down, what happens is it puts the normal the opposite way. So technically, if you're not holding shift, the normal would be off of the face out into space, but by holding the shift key you can get the opposite result and basically have the normal pointing inward toward the solid model, which is what we want. So keep that in mind. So now we can see that it's not centered in X and Y, but we can go ahead and snap this to the center no problem very easily. So the first thing that I want to do is just go ahead and click somewhere in space, and that way you have nothing selected. And what I'm going to do is click on one of these side faces that are flat, and then I'm going to rotate my screen, and I'm going to hold the control key, and I'm going to select the opposite flat side. And when you do that, you'll see that you have two opposing flat sides. And what I can do now is orient that to, it really doesn't matter here, either axis, either the X or the Y. So I'm going to go ahead and come down here and pick align Y, and I am not going to hold the shift key. So when I align Y, you can see here my Y axis is going this way, and we can see that the model is centered along Y now. And we're going to do the same thing. I'm going to click once on this side without the control key, then I'm going to rotate and hold the control key on my keyboard, and that way I can pick multiple elements. And here I'm going to go ahead and select align X. And let's take a look at that. So we can see now that our fixture is aligned via the XY plane at the bottom. The z-vector is pointed up into the fixture, and it's centered along the X and the Y values, both at 0 at center. So this looks pretty good. What I want to do now is maybe simplify the model a little bit, because there's some things that we really don't need, so why populate extra material or have larger file sizes inside of Esprit when we don't need it. So I'm going to hit F4 on my keyboard, and you can rotate your keyboard, or I mean your screen, but F4 gives me a nice planar view here. I'm just going to go ahead and click and drag my mouse and grab those mounting, I'll call them screws, to delete them. And this gets rid of those 4 solid elements. They have some threads, and it's really not necessary. Another small item that we can remove, we don't really need this. I'm going to go ahead and click and remove these 4 elements really quick on the model, because again, just simplifying the model a little bit, depending on how much fixturing and work holding and all that stuff you have, we want it to look as accurate as possible, but we don't need things that are in there that are going to be covered up by the stock, or here this area down here is going to be mated to another mounting plate or something, so they would be hidden from view anyway. So once we've done all this, we're ready to go ahead and start creating our reference positions for the workpiece that we're going to mount on each of these locations. So what I like to do is look at the X and Y, and this one here is aligned in the positive X, and so I'm going to call this the workpiece adapter for 0 degrees. So we've got 0, 90, 270, and 360. So let's take a look at this one here first. Now this is a dovetail, and we're not really sure exactly where the center here is, but we're going to go ahead and first snap our work plane to this top face. So what we're going to do is use a command here under manipulation called work plane from geometry. Now this says geometry, but you could pick solid elements, so I'm going to go ahead and just pick this solid face, and you'll see actually that looks like it's right in the middle there. So I'm going to assume that when 5th axis put this together, that's kind of the center. So if you machine your dovetail, in the center of that face, this is going to line up right here. So what we're looking at here, for me, I like, again, this is personal preference. I like it aligned with the U, the X, which it is, but I personally like to rotate it so the X is pointed up into, toward the center of the fixture. So what I'm going to do here is show another command under work plane manipulation. Click that bottom arrow, and what we're going to do is we're just going to select rotate UVW. Okay? So this command allows me to rotate about any of the UVWs. And here I have the UVW vectors, and here I want to rotate about my W, and I'm going to rotate this 180 degrees. So down here at the lower left, Esprit is asking me, what do you want to rotate U about? I'm going to say 0, V is going to be 0, so 0, enter, and then 180, enter. And my UVW rotates so that it's oriented the way that I like it. Now, I'm going to show another command here, which is a new command for us. It's the modify work plane, which is nice. You can just pick this blue arc that corresponds with the same color as the W vector, and you can rotate, type in and rotate whatever angle you want. So here if I were to say, like, let's say 90 degrees and hit enter, you see it rotates 90 degrees. I'm just going to hit Control Z and undo that, but you could use that command as well. So what we're going to do now is I snap to this face here, but I can see there's a little step, and my dovetail will actually be sitting on top of this face. So we're going to use the same modify work plane. This is the top one here, and I'm going to actually just click the blue W arrow for that modify work plane, and you'll see that no matter where I move my mouse, if I move it to here, it snaps to that position along the W axis. So I'm gonna grab this little corner here, and that's just going to shift this up slightly above this face, because really my dovetail is going to sit on top of that face. So, is something going to be that precise? Well, maybe. So we'll just do that, and then here I'm going to go ahead and say, let's create a new work plane, and we'll call this workpiece adapter underscore 0 degrees. I'm going to hit enter. And I like to also make a fixture adapter just in case maybe somebody's going to mount some fixture on top of this and then mount something to that. It's not typical, but I'm going to go ahead and do it anyway. So we have our 0 degree created. And now, looking at this fixture, it looks symmetrical in 4 quadrants. So what I'm going to do is just come here and say rotate. So we're going to go to manipulation, rotate work plane, and the first thing it asks for is the line of rotation. We're going to go ahead and select our z-axis, and then it asks for the angle of rotation. I'm going to put in 90 degrees. And when we look at it, it certainly appears like that is exactly where it needs to be. So we're going to come here and say workpiece adapter underscore 90, and then we're going to do one more again for fixture adapter underscore 90. Now we're just going to repeat that process 2 more times. I'm going to click on rotate, and you see here that it's already selecting a line, Z, and 90. So just hit your enter key 3 times and it will move it. And I'm just going to come here again, workpiece adapter underscore 180, and then fixture adapter underscore 180, and then come back to rotate and hit enter 3 times, 1, 2, 3, and the work plane moves to the last one, and we're going to do this again. Fixture adapter underscore 270 and workpiece adapter underscore 270. So real quick here, I noticed that these are all kind of out of order here. It's not a big deal. You can actually grab one of these and move it to wherever you want to reorder, or you can right click and actually say sort my work plane names by creation order. And you'll see here that they're all sorted by the order I created them, which is nice. So now I can see I've got my WA, my FA, again W and FA, 90, WF 180, and then both of the 270 degree. So we are ready to save this out. So I'm going to come to File, I'm going to come to Save, or Save As, doesn't really matter, and then pick a fixture GDML file type, the 4th one here from the bottom. And then we're going to go ahead and just type in our CAD model name. I'm just going to go ahead and copy paste this from the CAD model name itself, make it a little easier. And we can go ahead and say save. So looking at these items here, I'm going to go ahead and drag my Windows folder into view here, and we can see that I've done a lot of this family already. I don't need this CAD model anymore, I guess. So I'm going to go ahead and delete that. I have a GDML here, and now we're going to get into the machine tool builder. So I'm going to come and just double click this, and it will open up in Machine Builder. And the first thing I want to do is maybe just kind of rotate this a little bit so the view is a little bit more appropriate. You can come to View and say Set Preview, and then File, Save. So this will save my view now, so that if you're a user and you want to see really quick a preview of what it is that you're grabbing rather than looking at the file name, this is nice. You can also look at the preview pane in Windows. So if I maximize this, you can see the preview pane of these GDMLs, and if you're questioning whether or not one of these is the right one, you can rotate and get a little bit more different angles of the viewpoint, so you can verify that this is the product that you're actually wanting to load. So I'm going to get rid of the preview pane, but we can see here that we have this one. Now what I'm going to do here is sometimes you might want to maybe you have a workpiece that's a little bit bigger or something, and you don't want to use all 4 of these. You only want to use maybe opposing locations at 0 and 180. So we're going to go ahead and come in here and look at how we can do that. So here's our model that we just saved. And these are all the fixture and workpiece adapters that we created. And what I'm going to do here is expand this little green guy. There's a little plus sign there. And you can see here that each of these items has its solid model associated with it. So again, looking at the X value, let's say I want to keep everything at 0 and 180, and I want to delete everything that's at 90 and 270. I could just highlight the solids that are at 90 and 270 and just hit the delete key until I've deleted all of those models. And there we go. And now if I just click on, something else, I can see what my fixture looks like. And then since I deleted the 90 and 270s, I'm just going to delete these 90 and 270s here, and that way I'm only left with the ones that are located at where my little top mount tooling is located, these little dovetail vices. So now that I've created that, we want to be careful not to save this because we'll overwrite the other one. So what I'm going to do is just come here to File, Save As, and we're going to go to Fixtures, 5th Axis, and this is under my Rock Lock 52mm top tooling. And we have this one here. What I'm going to do is just put underscore maybe 2 positions and save that out. And now we can go ahead and use it in Esprit. Okay, so we have a machine loaded. We're going to go ahead and add a fixture to the machine. I'm just going to come to the samples folder, and I'm going to look at the subplate here, round, and I'm just going to pick one. We'll grab something like this and just put it on there. And then we're going to maybe I'll change that out. So even after you've done something, you can go ahead and pick something else. I want to pick something a little bit bigger. Then I'm going to go ahead and add another fixture to that, maybe a riser like this. So that looks okay. And then to that one, we're going to add the fixture that we just created. So I'm going to come back to Fixtures, 5th Axis, go to Rock Lock 52mm, top tooling, and I'm going to load the 2 position fixture that we just made with the 0 and 180. And we see it come, and you can see the reference position. So on this previous item, we set a fixture adapter at the top center. So the 0 point is now going to be snapped for this new one right to that position. So this modular style tooling is really nice. You just define where it mounts, and boom, it appears where you need it to be. So now on this item, I'm going to go ahead and select workpiece, and I'm going to go ahead and put this on the 180, and you can see here I'm going to move this up like, let's say, 2 inches here, because if this was like a dovetail, what I want is this to be mated to this face here, let's say. So we can see that if we were to have machined a dovetail, that's basically where it's going to be sitting on that. So I'm going to say OK, and then I'm going to right click on this workpiece and say copy, and then I'm going to right click on my multi-position fixture and say paste, and I'm going to paste it to the other position, 180, and I get both of my workpieces are now mounted. So I'm going to say OK, and we'll just let this run through a little bit and build my linking and everything for all of my operations. That some of these looks like it's 5-axis. So here we can see the both workpieces, both positions. I can, maybe these are a little bit big for this fixture, but you would be able to make this work with the right tools. So you can very quickly build modular setups inside of Esprit that You could quickly manipulate and change out work holding components. As long as you set up your reference positions correctly, you can very quickly put that digital twin together and simulate, simple or complex movements inside of a 5-axis machine like this, and be very confident in the NC code being sent to the machine. Here we see some work holding, we see some tool holders and everything that are supplied by OEM, so we know that this stuff is very accurate. And if I don't have any issues inside of Esprit, if all my linking, and operations can be executed without any collisions, then I know that I'm good to go. So hopefully this helps you guys make more accurate programs in Esprit, and if you have any suggestions for future videos, please let us know.